Alright, so we'll be looking at the volume and surface area practice questions. So first up, we'll look at the question 1. Find the volume and total surface area in each case. So in these questions, we get given all the information we need, and we just have to find the volume and the surface area. Okay, so let's start with question A. Question A. Okay, so here we have a rectangular prism, which means that the base shape would be, let's choose the base as the bottom part. And let's also write the formula for the volume of any prism. So let's just get rid of that for now. And let's write the base area, the volume of any prism. The volume of a prism is just equal to the base area, so the area of the base shape, base area, times by the height of the shape, or how tall or how deep or how long the prism is. Okay, let's underline that. That is our formula for the volume of any prism. And we just have to know the volumes for prisms. So that's all we need to know. Alright, question A. So let's start with the volume. So the volume of our prism equals the base area. Okay, so the base, in our case, let's call the base this green part. Okay, because that, we can call that the base because that shape stays the same all the way through the shape. So if you look at this rectangle here, you can stack lots of that same rectangle on top of each other and it'll form this shape, right? We could have also chosen this left-hand side, because you just stack lots of those rectangles next to each other and it makes a prism in this way. So the base has to be a shape that continues all the way through the prism until the other side. So the opposite side must have exactly the same shape. That'll be the base. So you can also think of the base as the two sides of the prism that are exactly the same. Alright, so we're choosing this one as our base. So the area of that, rectangle, times by this height, right? Let's choose another color for that. So times by this height. Right, so you stack lots of these green ones on top of each other all the way for this red arrow's length or height, and that gives you the total prism. So times by our height. Alright, let's continue. So the area of a rectangle is what? Area of a rectangle is length times by width. Okay, I'm just going to say W. Length times breadth, length times width, however you want to call that. And then times by the height of our prism, which I'll just call H. Okay, so that's going to be our H. And that's going to be, let's say, our length, and this part will be the width of our rectangle. Alright, so the length times the width, and let's also do this. So we can say it's the area of the rectangle times by the height, just so we know that this whole part is the area of the rectangle. Okay, so the length times the width of our rectangle, and that we're going to multiply by the height of our prism. In this case, that's 8, right? That's this height, 8. Okay, and then we just perform the calculation. So that's going to be equal to 30 times 8. Again, let's use the red just to keep consistency. So times 8. And then our final answer is going to be 240. And then if this was, whatever the units was, we need to include this. So let's say if this was all in meters, then we'd say this is cubic meters, or meters cubed. Okay, so whatever the unit is, you just write a cube if we're talking about volume, because it's got 3 dimensions, you see. It's got length and width and height. So 3-dimensional shape, which means there's a 3 there. Okay, that is question A. Good. Let's move on to question B. Okay, so question B, we still have, let me actually copy this formula so we can just reuse that and have that as a reference in each case. So here we have our formula for the volume of any prism. And we are now looking at the cylinder, the second shape. Okay, so again we're going to have our volume is going to be equal to the area of our cylinder, not the cylinder. What is the base shape here? Okay, our base shape here is going to be a circle because the opposite side is also a circle. So we know that can be our base. So this area, that's the same as this top area here. So that's going to be the base because the opposite sides are exactly the same. It's just a circle that gets taller. Alright, so the volume is going to be the area of our base, which is the cylinder. Not a cylinder, a circle. So the area of our base, area of that circle, times by the height of the shape, times by the height of the shape, of the 3D shape. So that's going to be the height of the cylinder. Alright, so let's do that. This is going to be our h value. So how do we find the area of a circle? Area of a circle is just pi times the radius of the circle squared, and then we're going to times that by the height, right? That's our formula. So this again is the area of the circle, so let me do that. That's the area of our base times by the height, and in our case we've got pi, and the radius of this circle is 10. I don't know if you can see that there. Let me just rewrite the 10. So this is a 10. Oh, let me write it down here. That's a 10, this part here. That's 10. That's our radius. So pi times radius squared. So that whole thing, we do different brackets to identify it better. And we're going to times that by the height of our shape. And our cylinder has a height of 20. So times by 20. Okay, so you see it's all the same. The area of the base times by the height of the shape. Alright, so 10 squared is 100. So 100 times pi is 100 pi. And then we're going to times that by our height of the cylinder again, which is 20. And if we do that, 100 pi times 20 is just going to be 2000 pi. Alright, and you can type that in the calculator to get a decimal. If you want to see that, let's get a calculator out here. So 2000 times pi, my times button, times pi. Oh, doesn't know what that is, so we find the pi of the calculator. And that gives us this value. So if we want to use a calculator, we can also write this value as an answer. And we then have to round this off to, let's say, depends on what we say in the test, right? So let's say if I say here round it off to one decimal place in the test, we're going to say that's 6,283 point, and now we have to round off to here, which means we look at this value, and if this value is bigger than 5, it changes that one to a bigger value, which will be 2. Alright, but this is completely fine. If you leave your answer in terms of pi, I'll be happy. It's easy to mark. You don't have to worry about rounding off. It's quite a nice way to do things. Alright, then we move on to question C. Oops. Let me just do this. Let's just make a couple of duplicates for all the questions. Alright, the next question. So again, let's bring our formula with us. Okay, so here's our formula, and we're looking now at the question C. Okay, so for question C, what will our base be here? Well, which shape is exactly the same on the two opposite sides? That's going to be this one, right? This triangle. Because on the other side, there's exactly the same triangle. So that's our base, because it's the opposite sides that are equal. So you can think about this as some triangle that just gets lots of triangles on top of it, pasted here, 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 all the way up to that side. That is then our prism. Okay, so we're going to have the volume, again, is the area of our base, and our base is a triangle, so it's the area of a triangle, times by the height of the shape, the height of the prism. Okay, so our height will be this one here. So that's the distance between the base and the opposite base, right? That's going to be the height of the shape. The distance between the two bases, if you want to think of it like that. All right. Now, a triangle, what's the formula for the area of a triangle? That is half times the base of the triangle times by the height of the triangle times by the perpendicular height. I'm just going to do this to show we have to be specific about the perpendicular height of the triangle. That whole thing is the area of the triangle. So that's our base area, and we're going to multiply that by the height of our shape, which we'll just call h. So let's call this h. Alright, so that gives us a half times the base of our triangle. So that's going to be this part here. That's 6 is our base, times by the perpendicular height. So 8 here is perpendicular, there's a 90-degree angle there. So 8 is our perpendicular height. And we're going to times that. So that's our area of our base. And we're going to times that by the height of our prism. So times that by 15. Alright. So again, that equals half times 6 is 3. 3 times 8 is 24. And we're going to times that by 15. And then we get our answer. And that's going to be 24 times 15. I don't know what that is. 24 times 15 is 360. Okay, 360. That is the volume of number C. Okay, so you'll see I'm doing the volumes first. I'll get back to the surface areas after I've done these volumes. Alright, question D. So let's again take our formula with us. Alright, so here we are at question D. So now, again, this is a triangular prism. So it's going to be the same thing, right? So our base is again going to be this triangle, because the opposite side is exactly the same triangle. So that is our base. Okay, so we're going to have our volume of this prism being equal to the area of the triangle multiplied by the height of that prism. Alright, now the area of this triangle, we know that's half times the base of the triangle times the perpendicular height of the triangle. Okay, and that whole thing is the area of our base shape for the prism. We're going to multiply that by the height. Okay. Right, and again we'll call this the height, because that is the distance between the two bases. Alright, so we'll see pretty shortly that we're missing something. Right, we've got the base here of our triangle, but we don't have a perpendicular height. Right, because this line is not perpendicular, that line is not perpendicular to our base, so this one is. So we need to find the value of that line. So let me get another color to do that in. What will stand out nicely here? Will the yellow work? Yeah, that stands out very nicely. Okay, so we want this height. Alright, now since we see these two arrows here and these two, not arrows, these two lines there, that means these lines are the same length. And if that's the case, then this bottom one is also split into two equal parts, which means that's split into 12 and 12. Okay, so I'm just going to take this triangle here and just redraw it over here. Okay, so that triangle there. So we know the bottom part there is 12, right? This section here. And we know this skew section, the hypotenuse, is 15. And then we can use Pythagoras' theorem to solve for this height h. Let's call that h there. So this will be h, that height. Okay, Pythagoras' theorem states h squared plus 12 squared is equal to 15 squared. Right? If you add the two small sides squared added together, you get the square of the hypotenuse. Okay, so that gives us h squared is then equal to, we want h by itself, so let's take the plus 12 squared over to the other side. So 15 squared minus 12 squared. So h squared is then equal to, so 15 squared is 225. Minus 144 will give us, what is that? 81. 81. Okay, and then we take the square root of both sides to get the square away, which gives us then h equals 9. Okay, so our height here is 9. That is 9. Oops, 9. Alright, now that we have that, we have our perpendicular height, we've got our base. So this is our base, that's our perpendicular height. So we can plug that in. So we've got half times the base of our triangle. But our triangle is not just this one, our triangle is this full one, right? This big one. So that one has a base of 24. So half times the base of our triangle times the perpendicular height of our triangle, which we found to be 9. And we're going to times that by the height of our prism. So times by 50, right? The height of our prism. Okay, and then let's calculate. So the area of our base, half times 24 is 12. 12 times 9 is 108. And we multiply that by the height of our prism, which is 50. And then let's calculate that, which I think is 5,400. 108 times 50 is 5,400. All right, 5,400. Correct. Okay, so you see it's pretty much all the same thing. In this case, there was just an added bit of Pythagorean theorem that we needed to use to find the perpendicular height. So if we just know our formula for the area, then we just know, okay, area of the triangle. Okay, what do we need for the area of a triangle? We need the base and the perpendicular height. We've got the base, we don't have the perpendicular height, so we need to calculate it. And then that's where we use Pythagoras' theorem to calculate that height. And once we have that, we just plug it in and type it in our calculator, and we have our answer. Okay. Last 3 questions on this. So find the volume, and so again, we'll start with just finding the volume of each of these. Okay, so we need the volume of a square-based prism with a side length of 5 and a height of 12. Okay, so we don't need to draw this, but I would suggest if you struggle to just visualize this from here, then you can draw it. It'll be nice to draw. So let me draw this first one. So a square-based prism. So let me say that's our square-based prism. And let's over here draw another square that's similar. Oh, I can actually, wait, let me do this. I've got a plan. Can make shapes like this. Okay, so there's our, let's say that's a square. Then we put another one like here. Let's do that. And let's just connect those lines. Okay, so we connect these lines, this one here to that edge, this one here to that edge, and this one here to that edge. Okay, so now we've got a square and we've got another square, so that would be our base, right? That's a square-based pyramid. So that's a square where all of these are the same length. So that side length, according to our question, is 5, right? So it's 5, 5, 5, 5. That's the length, the side length of our square. Let me put it inside here. Oh, I don't know where the best place is to put it. Put it there. 5, 5. Okay, so that is the length of the side of our square. But the prism has a height of 12, so it's going to be this distance here. That's going to be 12. Okay, but you don't need to draw that if you're happy just seeing the answers. I mean, just seeing the shape in your head or imagining it, that's fine. So again, the volume is going to be the area of our base, and our base is a square, right? Because it's square-based. It tells us that in the question, square-based. So the square is our base. So area of the square times by the height of our prism. Height of the prism. All right. So the area of our square, the square's area is just side times side, right? Or length times, you can also do length times width, because a square is also a rectangle. So you can also just say that's a rectangle, because every square is a rectangle. That makes more sense to you. And if we do that, then we can just say the volume is length times width. Okay, so let's say this is the length, and that's the width of our square. Okay, that's the area of our square. And that area of that square we're going to multiply by the height of the shape. So let's call the 12 here h, that part. Again, plug in our values. So length times width, that's going to be 5 times 5. And we multiply that answer by the height of our prism. And we solve that. 5 times 5 is 25. And 25 times 12 is 300. Let me make sure. Let me not lie to you. 25 times 12. Wait, sorry. Is 300, correct? Okay, that's the volume of our shape. Okay, let's just scroll down a bit. Where are we now? F. Okay, so a cylinder with a circumference of 12 pi and a height of 8. Okay, this one is a little bit trickier. That's sort of like number D, where we first have to find out something else. So a cylinder with a circumference of 12 pi. Okay, so we can start there, but I want to start us with drawing the shape first. Okay, just to show what's happening here. Okay, connect these places. Okay, so that's roughly our cylinder. And we don't know what the radius is, right? So let's just say this part here, that length, that's our radius, but we don't know what that is, right? So let's just call it R, right? That length there. Let's just call that R, this part, for radius, and then let's call this H for the height of our cylinder. Okay, now to find the volume of a cylinder, so let's write that down again. So volume of a cylinder, we need the area of the base, and again our base is a circle, right? Because on the opposite sides there's also a circle. It's exactly the same. So that's our base. And then the height of our prism will be this distance, because that's the distance between the two bases. Okay, so the volume of the volume equals the area of the base. And what is our base? Our base is a circle. So the area of that circle times by the height of the shape of the cylindrical cylinder, which is a prism. Alright, now the area of a circle is pi times radius squared. So that's the area of our circle. We're going to multiply that by the height of the prism. Okay, now we see there's a problem, right? We don't know what the R is. So we don't know what R is. So this part we don't know yet. So I'm just going to leave that open. I'm going to put brackets around that empty space for now. And then we'll find what this value should be here. Okay, so how do we get that? Well, we know the circumference of a circle. We know the formula for that. Circumference is equal to, let me just start up a bit higher. Circumference equals 2 times pi times radius. Okay, we know the circumference is 12 pi, so the circumference is 12 pi. That has to be equal to 2 times pi times radius. And now we want radius by itself, so we can just divide both sides by 2 pi to get rid of the 2 pi. Because then 2 pi and the 2 pi will cancel out. So that leaves us with R, the radius. And on the other side, pi cancels with pi, and 12 divided by 2 is 6. So the radius is 6. Now that we've done that, we can fill in our radius value and just solve, or just find the solution here. Oh, I forgot to put in the value for h here. We know h's value. We know that is 8, right? This is the value for h, 8. All right, 6 squared is 36. So 36 pi times 8. So 36 pi times 8, 288 pi. So that's 288 pi. Because we had 36 pi's and we times that by 8. That's 288 pi. That's the volume of this cylinder. Okay, then we have a triangular prism. Okay, so I'm just going to go down here and make some space. Okay, so now we have a triangular prism with an base area of 30 and the prism's length is 20. Okay, so again, there's not much we need to, in this case, I mean this one you don't even need to know what it looks like, but I'm going to draw it anyway. And it doesn't matter what shape your triangle takes. So let's do this. And let's make that into a nice prism by connecting these lines. Okay, so they tell us all the information we need. So let's first write it on the formula again. So the volume of a prism is the area of its base. In this case, what's the base? It's this triangle, right? Because this triangle looks exactly the same on the other side. So that means that's the base. And then h, our height, will be the distance between them, so it's that length. That's going to be our h. And they tell us that is 20. But before we get to that, let me just write h here. Oops, h. All right. Yeah, I want to write here area of the triangle, because we saw the triangle is our base, so it's the area of the triangle, area of the base, times by the height of the prism, times by the height of the prism. Okay, area of a triangle is half times the base of the triangle times the height, but we don't need any of that, right? So if you came to this spot here, you've already done too much, because they tell us what the area of the triangle is, right? The base area is 30. So the area of the triangle is 30. And it's going to times that by the height of the prism. And they say the height of the prism, or the length of the prism, is 30. Not 30, 20. Okay, so the base area is 30, and then the height is 20, so we just times that. Right, so all we needed to do here is read properly. And that gives us 600. Okay, they give us the area of the base, so we don't have to work it out. And they give us the height or the length of the prism, so we don't have to work it out. And that's it. Okay, so I think that wraps it up for the volume portion of these practice questions. I'll post another video with the total surface area questions. All right.